All right, hey guys, so we're going to be taking some quick notes in 6.7b. So make sure you find this guy in your packets and away we go. So we talked about the fact that you do not have to factor a quadratic to find its roots. So if you have just a plain x squared equals 16, so this would be different than if you have, say, x squared plus 2x equals 16, okay? With this one, because it's a singleton on either side, singleton equals singleton, one guy equals one guy, the inverse of something to the squared is a square root. So I could take the square root of both sides, but don't forget, we have to put a plus or minus. So what this allows us to do is avoid having to move the 16 over, factor both sides, and then set each piece equal to 0. Notice how you'll get the same answer either way. This way was just a lot faster. You cannot, and I'll even draw it in red, this you cannot do. This is illegal. And the reason that it's illegal is because on this side, it's not a singleton. You've got two guys. All right? Now, we can do the same thing with the x squared equals 50. The issue with the 50 is it's not a perfect square. So when I go in and square root both sides, I'll get x equals plus or minus the square root of 50. And we learned about simplifying radicals. To simplify a radical, you look for the biggest perfect square. So the biggest perfect square that goes into 50 is 25 times 2. Now, the square root of 25 is an integer. The square root of 25 is 5, so he can come out. And then on the inside is going to say 2, because the square root of 2 is irrational. It's a decimal that goes on forever and ever. All right. Now, when we get to part C, it's a little bit disturbing. And the issue is because I don't really just have plain x squared. The guy that's standing in that way is the divided by 2. So to get rid of divide by 2, I'm going to apply an inverse operation. The inverse operation I'm going to apply is to multiply both sides by 2. So 2 times x squared divided by 2 is just plain x squared, and 10 times 2 is 20. Now, since I have a singleton equals singleton, I can square root both sides. X equals plus or minus rad 20. And then I can go prowling for perfect squares. The largest perfect square that goes into 20 is 4, and it's 4 times 5 is 20. And then we know the square root of 4 is 2, and the square root of 5 has to stay underneath the radicals. So those are our two answers, all right? So again, guys, what we're going to do is we're going to be using inverse operations. So when we look at, say, this guy, you have a couple of options. You could, A, try to factor him. And when I read this, it says use inverse operations. In each case, your answer will be rational, meaning it'll be an integer or a decimal, okay? And so notice how I am missing a plain x term in this first guy. So what I'm going to do is I'm going to subtract the 10 over. So I'm left with 2x squared equals 28 minus 10. That's plain old 18. And then last but not least, if I want to get that x squared alone, if I want to try to use the skills I was using in the previous questions, hey, look at this. X squared is equal to 9. To get rid of that x squared, I can square root both sides, and x is equal to plus or minus the square root of 9, which is 3. All right, so that was easy, very straightforward. We've got a nice rational number. All right, now guys, this is, oopsies, pretty similar. Notice how I have a something squared equals a number. So I can get rid of this quantity squared by square rooting both sides. And so what I'm going to get rid of is this squared when I square root, so I'm just left with x minus 2. And to be honest, you don't need those parentheses, so I'm going to move those in a second. The square root of 25 is 5, but since I had a quantity squared, we know we talked about we're going to do the plus or minus. So here we have x minus 2 equals plus or minus 5. My goal is to solve for x. The guy that's keeping x from being alone is this minus 2. So I'd like to move him over here. And when he changes sides, he changes sign. Now I'm going to put him in front, and you'll see why. Shoot, that's a 5. Okay? Because this is two little mini arithmetic problems. It's 2 plus 5, and it's also 2 minus 5. So our two answers are 2 plus 5, which is 7, and then my other answer is 2 minus 5, which is negative 3. Okay. Part 2. It wants us to find the zeros of each of these functions. And so, guys, really the difference is when you see zeros, notice how they didn't have it set equal to 0 for us already. That's all they want us to do. So set it equal to 0. That's how it wants us to start. Same thing here. They want us to take this bad boy and set him equal to 0. And again, in each case, our answer will be rational numbers, meaning either a fraction or a plain integer. So let's go. I think I can make this guy look like part B above. If only I move that 4. So let me do that. If I move the -4 over, he changes sides, he changes signs. And now I can square root both sides. That gets rid of the squared on the left, and the square root of 4, when I go from a square to a square root, is plus or minus 2. Last but not least, I can take that 1 and move it over. And so my little guys that I have is 1 plus 2, which is 3, and 1 minus 2, which is -1. And those are my two answers. All right, let's run through this guy, letter B. So I want to try to emulate what was happening in B above. So notice I want this chunk all by himself. So the first thing I got to move is that -200. He's going to change sides. He's going to go over here. So when he changes sides, he changes sign. I can't square root it just yet because of this 2. So I got to get rid of him, okay? You guys should know this is multiplication here. So the inverse of multiplication, that's why this day is called inverse operations, is division. So I'm left with x plus 5 squared equals 200 divided by 2, which is 100. I like this because now when I square root both sides, I'm left with x plus 5 equals the square root of 100, 10. And then last but not least, I can take the 5 and change the sides. And if he changes sides, he changes sign. So I'm left with -5 plus 10 and -5 minus 10. So my solutions are +5 and -5 minus 10 is -15. I know I'm going really fast, guys, and I'm just trying to get this whole page in as quickly as possible, okay? So last but not least, now this one, it says solve using inverse operations, express your answer in simplest radical form. So my answers are not going to be as nice as the ones above. So again, I can get this x squared alone. The first thing I'm going to want to do is add the 2 to both sides. 38 plus 2 is 40, right? Now I got to get that x squared alone. I've got the 5 standing in the way. The inverse of multiplying by 5 is dividing by 5. 40 divided by 5 is 8. And then last but not least, I'm going to square root both sides. And this would be a fine answer if they didn't demand we leave it in simplest radical form. When they say that, we know we have to go prowling for perfect squares. The perfect square that goes into 8 is 4, and it's 4 times 2. The square root of 4 is 2, rad 2. So that's in simplest radical form, okay? I like this last one because it sends round to the nearest tenth, which means after I do the algebra, I can use my calculator. So this is like all of the part B's we did above. I got to move that 10 over, though, first. So if I subtract 10 from both sides, I'm going to have equals 28. The inverse of something squared is the square root. So what I'm doing is I'm square rooting both sides. Oops, forgot the plus or minus. And then last but not least, I'm going to snag that 2 and I'm going to move them over to the right. And now the reason that I'm saying I'm not looking for perfect squares that go into this is because it wants me to round to the nearest tenth. So I'm going to type in 2 plus rad 28 and 2 minus rad 28 on my calculator and get those decimals. And those two decimals are the answers that they are asking for. Make sure you round to the nearest tenth, which is 1 decimal place. All right, guys, that is enough for today. I will see you next class with another fun video.